In this chapter, we study the most important continuous probability distribution in statistics, called the normal distribution. Normal distributions are bell-shaped curves that model many sets of measurements in nature, industry, and business. For example, heights, weights, and blood pressures of humans, lengths of pregnancies, lifetimes of washers and dryers, and even housing costs are all normally distributed. Properties of a normal distribution. The graph of a normal distribution is called a normal curve. A normal curve is bell-shaped and can be graphed using this function formula right here. Property 3, the mean locates the center of the curve. If, for example, and watch the blue curve, right now we see the blue curve is centered at 5. If I move that back to say negative 2.2, you see what happens to the center of the normal curve, okay? And the entire normal curve, it's centered right at the mean. That's an important property to remember. If you can draw a vertical line right through the mean, then this vertical line is said to be an axis of symmetry. And what that means is the left half of the normal curve is a mirror image of the right half of the normal curve. For every normal curve, next property 4 here, for every normal curve, the area underneath the curve is always equal to 1. And the significance of the total area being 1 is that 100% of the probability is represented underneath the normal curve. Property 5, the normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. That means that we can zoom in here, and it doesn't matter how far down the x-axis we go, you can always do a zoom in and see that the normal curve is above the x-axis. So even though, let's go back here to reset over here by the origin, even though it looks like this right curve, or I'm sorry, the blue curve here on the right, it looks like it's going to touch the x-axis. It never does intercept the x-axis. And we use a limiting formula in calculus to establish that result, and you can see it in the graph of the curve. That also happens on the left side of the curve. No matter how far down the x-axis in the negative direction you go, you'll always be able to zoom in and see that the normal curve is above the x-axis. Not on top, but just above the x-axis. So property 5 tells us that the normal curve never intercepts the x-axis. Property 6. Property 6 tells us that there's 2 points along the x-axis, 2 x-coordinates, mu minus sigma, which is 1 standard deviation, length below the mean, and mu plus sigma, which is also 1 standard deviation, but this point is above the mean. For each one of those x values, there's a point on the graph of each normal curve, and between the 2 inflection points, you've got the graph of the normal curve bent up or concave up. And then outside of that interval, the graph is bent down or said to be concave down. So the inflection points will mark a change in the way that the graph is bent, or this is called a change in concavity if you're a math person. But once again, the graph is concave down or bent down between these 2 points, which are 1 standard deviation below and above the mean. And outside of that, again, the graph is bent up or concave up. Okay, so the property 6 just says that there's the inflection. Property 7, the population standard deviation, sigma, describes how spread out along the x-axis that the probability density function curve, or the normal curve, is. Large values of sigma decrease the height of the peak and increase the spread of the normal curve along the x-axis, and small values will raise the height of the peak and decrease the spread. So one way to illustrate this is over here on the right. Notice again the blue normal curve. Right now the standard deviation is set to be 4. If we lower that standard deviation, the graph gets less spread out along the x-axis, right? The normal curve gets more narrower and skinnier. But what happens to the normal curve as you raise the standard deviation? It becomes more spread out. The normal curve becomes more spread out along the x-axis. The peak is a lot lower, right? And keep in mind, for every time I change sigma here, I get a different normal curve. And each one of these normal curves has an area of 1 underneath it. Take a minute to see if you can do questions 1 through 4 using the graph on the left. To answer question 1, it looks like B is the curve which has the largest mean, and that's because each one of these normal curves is centered at the mean, and the normal curve B, you can see, has a center at 60, so the mean of that curve is 60, whereas curves A and C are centered somewhere around 45 right here, and so their means are 45, which is less than 60. So for that reason, the question answer number 1 is B. Question number 2, which normal curve has the largest or the greatest standard deviation? And that's of course going to be A. And the reason that is because A has the tallest peak. It is also the narrowest and skinniest of the 3 curves. Question 3, which normal curve has the least standard deviation? That's going to be C, simply because it's the only curve out of the 3 curves that has the shortest peak, and you can tell that the graph is more spread out along the x-axis compared to the other 2. And question 4, what equation describes the line of symmetry, or the axis of symmetry, for the curve C? And the answer to that is the equation x equals 45, which represents a vertical line if you graph that in 2 dimensions. So the vertical line equation x equals 45 describes the line of symmetry. Question 5. The scaled test scores for a New York State grade 8 math test are normally distributed. The normal curve shown below represents this distribution. What is the mean test score? And also estimate a value for the standard deviation of this normal distribution. Okay, one thing you need to know here is that scaled test scores really are curved scores. So up here when it says that the test scores are scaled, it means these are all curved scores. And one question I will typically get is, well, what does it mean for? One question I typically get is, what does it mean to say that test scores are normally distributed? The answer to that is this. It means that if we had the entire list of test scores and we graph that list as a relative frequency histogram, that histogram would be bell-shaped, and furthermore, it would look like the picture in the graph here. And if you take a look at the question, it asks us to find the mean. And of course, the mean locates the center of the normal curve. So the mean is going to be right here. And it looks like the mean is right directly in the center between 650 and 700 along the x-axis. And the halfway point between 650 and 700 is 675. So that establishes that mu, the average here, is 675. So the average test score is 675. And they also want us to find the standard deviation of the normal curve. So if you take a look at the x-axis, and in particular I'm looking at the space between 650 and 700, it looks like these ticks are measuring out 10 units. So this is 650, 660, 670, 680, 690, and so on. And the reason I bring that up to help us find the standard deviation is these points right here are the inflection points, right? And we know that the inflection points mark the location where there's a change in concavity of the normal curve, but more importantly for us, we know that this point, which is 710, is exactly one standard deviation length above the mean. This point right here along the x-axis is at 640. Okay, and this point here, 640, is one standard deviation below the mean. Okay, so to find the standard deviation, what we're going to do here is the standard deviation is really just this length right here, the length between mu and 710. So there's mu along the x-axis. There is the point mu plus sigma, which is one standard deviation above the mean. So therefore this distance here is just sigma, right? The difference between these two numbers is the distance between these two numbers, and that minus that is sigma. Okay, so this length here, it looks like this length here is sigma, and of course that's just going to be, well, let's see here, there's 10, 20, 35, so it's 35 units. Okay, so sigma is 35 units. So that brings us to the more important things that we've got to do in this section. And one big game that we play in this section is using normal curves to find probability. And that's because we have this theorem that's been proven, and that theorem, we use calculus to prove it. But the theorem tells us that the probability that x is between a and b, so take a look at this image on the left, right? If we want this probability, the probability that x is between and including a and b, this theorem tells us that all we have to do is find the area underneath the normal curve between those two vertical lines at a and b. One easy, quick way to do this is to use what's called the calculator's normal CDF command. And I'm going to show you how to do that right now. So we'll take a look at this question. It's question 6 here. Use the calculator's normal CDF command to find the probability that a randomly selected test score is between and including 600 and 650. So here, the random variable x is representing the test scores, the curve set test scores. And the question asks us to find the probability that x is between and including 600 and 650. Okay, so according to the theorem, this probability is nothing more, the probability that x is between and including 600 and 650 is nothing more than this area underneath the normal curve between 650 and 675. Quick way to find that is to use the calculator's normal CDF command. And when you use the normal CDF command, the calculator is going to ask you for four things, or you have to give the calculator four things. You have to tell the calculator the two numbers that you want the area between. So these are called a lower boundary number and an upper boundary number. Okay, and for this problem, the lower and upper boundary is 650 and 675. The lower and upper boundaries are the two numbers that you want the area between. And you also have to tell the calculator where the normal curve is centered, so you have to give it a value of mu, and you also have to tell the calculator what the standard deviation is. And one question I usually get here is, well, do they always tell you what the mean and the standard deviation is if it's a probability question related to a normal distributed random variable? And the answer is yes. They have to give you some way of finding out what the mean and standard deviation is. And so we're going to access the normal CDF command and enter in these four numbers. To access normal CDF, you're going to press the second button. Then you're going to press the VARS button. This is how you can access all of your calculator's distributions that are programmed into it. Okay, so over here I'm pressing second VARS. This window pops up, and notice that 1 is normal PDF and 2 is normal CDF. And we never use normal PDF, okay? Normal PDF is a command that's used for drawing normal curves in the calculator. We are not going to need that command, but we do need the normal CDF command. That's the one that gives us the area underneath the normal curve. So if I press the 2 button, then for this calculator, I get a settings window like the one that I'm getting. And you can see that my flashing cursor is asking me. And you can see that in the settings window, this is where you give the calculator the four inputs. Now, if you have the other calculator, and I'm going to do the problem on that calculator in a second, it's slightly different. You're going to press second VARS 2, and when you do that, instead of getting a settings window like this, you're going to just have the calculator is just going to paste the normal CDF command to the calculator's home screen. So in both cases, the next step is to tell the calculator or enter in these the four values here. So if you happen to have this calculator here, the lower boundary, we need to tell it, oh, it's 650. Hit enter, and notice that brings our cursor down to upper. Upper boundary is 675. Hit enter. And then tell it where the mean and the standard deviation is. So this is 675, and hit enter, and 35. Okay, and now I'm going to paste. Enter that in. So now I'm pasting that normal CDF command to the calculator's home screen, along with the four input arguments that the program needs. And when I hit the enter button, it gives me the probability. Over here on this calculator, the TI-83, to do the same thing, you're going to press second VARS 2. It pastes the normal CDF command to the calculator's home screen, and you have to manually enter in the four inputs. So we're going to do that now, 650. And the inputs have to be separated by a comma, so notice the comma is right above the 7. So 650, 675. comma, now tell it what the mean is, 675, comma, 35, the standard deviation, and then hit enter. And that's how you get the probability that x is between and including 650 and 675. So the correct answer here we got for that is, oh, let's round this to the 10,000s. We're getting that this is about 26% or 0.2625. So whenever we do a probability problem or we're asked to find a probability, this type of problem just equates to finding an area underneath a normal curve. And the quick way to get the area underneath the normal curve is to use the calculator's normal CDF command. And so whenever you play this game or whenever you do this, or you're asked for probability, there's 3 different cases that you're going to get. And let's talk about the 3 cases now, and I'll give you an example of how to deal with each. I always recommend that when you do a question of this flavor, that you always draw out the normal curve, locate the mean at the center, and locate your boundaries, your upper and lower boundary, and shade the area between them. Okay, so the 3 cases are over here. Case 1, if you need to find the probability x is between and including a and b, or the probability that x is between a and b but not including a and b, those 2 probabilities are going to be the same for any continuous random variable. We saw that that wasn't true for discrete random variables, but here it will be. And so for both problem types, it's the same answer. You're just going to find the area between the upper boundaries a and b. And so to use normal CDF, you're just going to, of course, press second vars 2, and then you're going to use these 4 input arguments. Your lower boundary will be the leftmost boundary, right? And B will be the upper boundary, the rightmost boundary. This is you telling the calculator what 2 numbers you need the area between. And then, of course, you tell it the mean and the standard deviation. This is always given in the statement of the problem. We just did a problem like that. But another type of problem is finding the probability that x is less than or equal to some number b, or just strictly less than some number b. And both of these probabilities are going to be equal to each other. So both, it doesn't matter which one you're asked for, you're going to get the same area. And here, if you take a look at the picture on the right, there's no lower boundary. So technically there's no a. There's no lower boundary, or the lower boundary is negative infinity, technically, and that comes from examining the equation that graphs the normal curve. We use some limiting process in calculus to show that the left boundary here will be a negative infinity. And so what you need to do for your left boundary is to approximate negative infinity. And the way I do this is to use negative 10 to the 9 in place of a here. And then you tell the calculator what your rightmost boundary b is, and the mean and the standard deviation. The third case, we're asked for the probability x is greater than or equal to a, or simply the probability x is greater than a. In our picture, we're locating the value a. We're shading to the right since it's a greater than, or greater than or equal to. Whereas up in the second figure, since we're being asked for less than or equal to, we should be shading the area to the left of b. But going back over here to the third case, your graph should look like this. And your lower boundary will be the number a. Your upper boundary will be infinity, but I approximate the upper boundary or infinity as 10 to the 9. Okay, so that's the syntax for the 3 different cases. Let me give you an example, and that example will be right here, problem number 7. So in problem 7, we're told that a Honda diesel motor is used to run each packaging assembly line at the potato chip factory. We're told to let X represent the lifespan of one of these motors. So And accepted values for the mean and standard deviation, we are told, are 25 years and 2 years respectively. Suppose that the probability distribution of x is normal. What is the okay, so now question A here. What is the probability that the lifespan of a randomly selected motor or a randomly selected x will be not more than 23 years? And in B, at least 23 years, and C, between 23 and 25 years. Okay, so here's how I'm going to answer those three questions. Okay, so the question A, the notation that we use for that, not more than 23 years, we know that that is equal to a less than or equal to symbol, a minimum of 23 years. So the notation that we use for that question is the probability x is less than or equal to 23. And so that's equal to an area underneath the normal curve. And that normal curve is centered at mu equals 25, right? Because we're told in the statement of the problem the average lifespan is 25 years. We also know the standard deviation is 2 years. So we're going to locate 23. It's left of center. And because the question is asking us for a less than or equal to, we're going to shade to the left of x equals 23, because that's the area that we need to find this probability. So the correct notation that we use for this problem, that's this here. The correct picture ought to look something like this here. A picture of a normal curve centered at 25. 23 is located to the left of that. And again, since it's a less than or equal to, we need the area left of 23. So to get that area, we're going to use the normal CDF command. And here there's no lower boundary, or the lower boundary is at negative 10 to the 9, which is a good approximation of infinity. So I need to tell the calculator I need the area between these two numbers, negative 10 to the 9 and 23. So those are my lower and upper boundaries. And then we tell the calculator what this mean is first, and then the standard deviation, which is 2. Okay, so now I'm off to do the calculator part. Here we go. So I'm going to press second vars, 2, and my lower boundary needs to be negative 10 to the 9. So I'm going to use this button down here and not the subtraction button, because if I use the subtraction button, I'll get an error. So if I want to write 10 to the negative 9 power, I need to first mark the answer negative by pressing this key here, and then 10 to raise 10 to the 9th power, I'm going to press this button here, the caret button, and 9. The upper boundary is 23, and the mean 25. Standard deviation is 2. So we'll go ahead and paste that in and hit enter. And we're getting our area, which is about 15.8% or 0.1587. So I've started rounding my probabilities to the 10,000th decimal place, and there's good reason why I'm doing that, and I'll tell you about that later. If you happen to have the other calculator, to find the same area, it's a little bit more work because you don't have that settings window. So we're going to press second vars, 2. This will paste the normal CDF command to the home screen. And once again, I'm going to press this button down here and not the subtraction key, to mark 10 to the 9th negative, and the commas above the 7, and the upper boundary is 23, comma 25, comma 2, and then hit enter, and we're going to get the same area. Okay, so that's the first of 3 different possible cases that were mentioned over here. Right, we did, I guess that wasn't the first, but anyway, we did a problem like this. That was the first problem I did, but we just got done doing a problem like this right here. So that's case 2. Question B asks us to find the probability that a randomly selected lifespan is at least 23 years. And so they want us to find the probability that x is greater than or equal to 23. And in part C, they want us to find the probability x is between 23 and 25. So the way to write that is this. Okay, and in part A, we found the probability that x was greater than or equal, less than or equal to 23. Okay. So moving on to B here. So if we want to get this probability, then of course that's just going to be equal to the area left of 23, to the right of 23, and there's a couple of different ways we could get that area. Probably the easiest way is to use the fact that the total area underneath this curve is 1. We already know from that previous problem that the area of that white space there is 0.1587. But since the total area is 1, we know that this is true. We can just take the total area, which is 1, and subtract the area left of 23 from that. So there we use the we just use the fact that total area is 1, right? We know the area to the left of 23 is 0.1587. So to get the area to the right of that, which is what the question B here is asking us, we just subtract that a number from 1. So if you wanted to confirm that that was the correct answer, you could also use the normal CDF command, right? Alternatively, we could call on normal CDF. I'm going to abbreviate that as NCDF just for the sake of some space here. And the lower boundary is 23. The upper boundary is infinity, or 10 to the 9. And then, of course, the mean is 25 and standard deviation 2, respectively. Okay, so we'll go ahead and do that now on the calculator. So I'm pressing second vars 2 and give it the new information. The lower is now 23. The upper is 10 to the 9. And let's see here, same standard deviation and mean. And indeed, we're getting that same go back over here, as I said, there was 3 different cases, or 3 different pictures, 3 different types of pictures that you could draw here. And for question A, we had case 2 here. We shaded to the left of B. For question B, we had case 3, and we're shading the area to the right of A. And now on question C, it's just like case 1 here. And so our picture should look like this. Okay, so the probability X is between and including 23 and 25. We know that that's equal to the area underneath the normal curve, centered at 25, and of course it's between those 2 values. So we're going to call on normal CDF again, and we're going to tell it what the lower and upper boundaries are, 23 and 25. And we're also going to tell it what the mean and the standard deviation is. So I'm going to clear that off and press second vars 2 to paste the normal CDF command to the calculator's home screen. 23, 25, 25, 2, and then hit enter. Right over here, same thing, pressing second vars 2. Get the settings window there, and just tell the calculator what I need for lower and upper boundaries, paste in, and bam, bada bing, bada bam, we're getting the answer is about 34%. And again, I'm rounding to the 10,000ths, which is what we typically do for probabilities related to a continuous random variable X, related to a normal random variable. Okay, so now I'm going to go over a couple of the lab problems. I should have sent you the solutions to that already, but let's take a look at some similar problems that ask you to find probability. You're going to see these kind of problems in the homework and in the labs and in your quizzes. So in question 1, let's see here, exercises 1 through 3, we're told that the random variable X is normally distributed with a mean mu of 174 and a standard deviation sigma of 20, and we're going to find these probabilities. So in question 1, we want to find the probability that X is between 172 and 192. And so to get that probability, we know that that probability is equal to this picture here, right? Just the picture of a normal curve centered at 174, and the lower and upper boundaries will be 172 and 192. We need the area between that because that's what the probability is equal to. So our upper and lower boundaries A and B from the normal CDF command will be 172 and 192, and we tell it what the mean and the standard deviation is to get that answer. So over here on the calculator, that's real easy to find that probability. We're just going to press second vars 2 and type in 172, 192, 174, 20, and then hit enter. And that's and I rounded to the 10,000, so that's how I got that answer. So moving on to question 2, which asks us to find the probability X is less than 200. We know that that's just equal to the area left of 200. It's a less than. It's a less than in the statement of the question. And so that means in our picture, we're going to be locating 200 along the x-axis to the right of center, to the right of 174. And that's because 200 is larger than 174. and we're shading to the left, okay? So since it's a less than, we're shading to the left of 200. That's the area we want. And in this case, technically there's no lower boundary, but we're going to feed in negative 10 to the ninth as our lower boundary. So that's an approximation of infinity. And so on the calculator to do that, we're going to press second vars 2 and type in, remember we're going to use this key down here, not the subtraction key, so we don't get an error, to mark 10 to the ninth negative. And we use the caret key to raise 10 to the ninth power, commas above the 7. And it looks like I got 0 there, and that's of course because I made a mistake. Notice there's no comma up here between the ones. So instead of typing all that again, I can press second enter. I pressed second enter. And that brings up the previous entry in the calculator. And I can just use my my arrow buttons to move my cursor where I want it. I'm pressing a comma there, and now I need 20 after that. So boom, there's my total area, which rounded to the 10,000ths is about 0.9032, or about 90% on this calculator. It's similar. I press second vars 2, I get the settings window, and now I have to tell the calculator what the lower and upper boundaries are. Okay. Moving right along to question 3. Question 3 asks us to find the probability x is greater than 155. So we just need the area to the right of 155 since it's a greater than. And so our picture ought to look like this. 155 is less than 174. So we're locating 155 left of center in our picture. So once again, it's a greater than, and that's why we shade to the right. So our lower and upper boundaries will be 155 and 10 to the ninth. And so I'm going to press second vars 2. Paste that in, and that's how I got the correct answer.